Okay, this is section 5.4. We are going to talk about exponential and logarithmic equations, different ways of solving it. We're actually going to see three different kind of problems that we will solve in this section. But first, let's talk about exponential. As you might remember, in section 5.1, we talked about a basic way of solving exponential equations. Just to remind you, an example of that would be something like this. If we had 2 to the x equals 8, we were able to solve this if we could get the bases to be the same, and 8 is 2 cubed. So since we could get them written in terms of both 2's, we can assume that x equals 3. Okay, this was from section 5.1. Okay, and this was only when we get the bases to be the same. Okay. So now we skip over and we're at the end and we're back to exponential equations. What happens when you can't get the bases the same? So this example we have, the first one is showing you what we do. Alright, so we have 171. Okay. Obviously we cannot write these as the same base. So what can we do? Well, the way we approach this is, in equations, anything you do to one side, you have to do to the other. Like if you add, you have to add to both sides or subtract. Same thing goes with logs. You can actually take the log of both sides. You can take the log or the natural log. Okay? This one, because they particularly asked us to express the solution in terms of natural logs, we'll use natural log. But so basically, you can take the natural log of both sides. Right? It's okay to do as long as you do it to both sides. By doing that, the property we learned in the last section, which told us when you have a log of a number to a power like this, that power can come down in front. So it's really a great rule because it's the only way that we can get x out from underneath, out from the exponent and bringing it down to a normal level, right, to the regular level, so we can solve it. Sorry, that's a little messy. 4.71. Okay, so we take the log of both sides, bring the x down from out of the exponent in front. Now we have x times the natural log of 10. And keep in mind, natural log of 10 is just a number. Same thing with natural log of 4.71. It sticks together. So all we have to do is divide both sides by natural log of 10. Those cross out. So we have this as our answer in terms of natural logs. Okay, this is what you'll enter right here into that first part. Write the solution in terms of the natural logs. Okay, on the test, this is what you'll see. This is all you'll have to do. Now for homework, they ask you a part 2 that says what's the decimal approximation. It really is, it's set up this way in Pearson, and it was kind of too hard for us to take that second part out. So for the homework, in order to get the decimal, you're going to have to pull out a regular calculator. Okay, it's definitely going to be a decimal, so pull out your calculator on your phone, or if you have your graphing calculator or scientific calculator, to calculate this just for the homework to get it complete. So if I plug this into my calculator, I would get 0.67. It does say round to 2 decimal places. Okay, that would be what you enter in the second part. Okay. Okay, for this number, this example, we have solved the exponential equation, express it in terms of natural logs, use the calculator to obtain the decimal approximation within 2 decimal places. All right, this is just like the last one. So if you notice, we have 4 e to the x equals 19. Okay, so we're going to take the log of both sides, natural log, because they specifically said put it in terms of natural logs. But before I take the natural log, I'm going to get rid of the 4. So I can divide it out and get e to the x equals 19 over 4. All right? So from here, now I want to get x out of the exponent. So what we can do is we can take the natural log of both sides. Okay, so this is the natural log of all of this, 19 over 4. Okay, the natural log, if you remember that base, the property, remember natural log is the base is an understood e. Remember our shortcut property, when the bases are the same, the e's are the same. this cancels out and just gives you x. So x equals the natural log of 19 over 4. That's my first answer. This is what would be asked of you on the test, okay? But then they do want us to do a second, step 2, plug that into our calculator. And I got 1.558, and that rounds to 1.56. Okay, here's another example similar to the last one. We have 8e to the 9x equals 864. Okay, we're going to take the log of both sides. First thing, let's clear that 8 out and divide it out to the other side so we can get e by itself before we take the natural log. 8 goes into 864, let's see, 108. Now we can take the natural log of both sides. Natural log of e to the 9x. Natural log of e to the 108. Okay, take the natural log of both sides. The reason we do that is now that allows us to take the 9x out from the exponents. Remember, natural log of e, that just cancels and just gives you 9x equals natural log of 108. We're almost done. We're solving for x, so we can divide out both sides by 9. This is so similar to the last one. The difference is now the natural log is divided all by 9. And that's our first part. And then, let's type it in. We have the natural log divided by 9. And I got 0.52. Okay, this is the last one of the exponential equations that we'll see, but I wanted to show it to you because there's one like this in the homework. So we have 4 to the x plus 2 equals negative 5. Obviously our bases are not the same, so we can take the natural log of both sides. Okay, but look at the right here, this one right there. Okay, if you notice it's the natural log of negative 5. Well, by definition, I talked about this earlier, you can never have the log of a negative number. So this makes no sense. Therefore, there's no solution. Okay, here we are to a logarithmic, our function, the equations that we have. This, if you notice, we have log base 2. 5x minus 6 equals 3. Okay, so to solve logs, we've actually done some like this before. We have to get rid of the log, and since we have a log base 2 equals 3, we just need to convert it to exponential form. So let's convert to exponential. Okay, remember how we do this. We start with the base, right, which is the 2. Then we go counterclockwise. 2 to the 3 equals 5x minus 6. So that's how we convert, just a counterclockwise, starting with the base. Now we're left, if you notice, we have 2 cubed is 8. There's no more log in the equation. It's just a basic equation that you can solve pretty easily. So let's add 6 to both sides. We get 14 equals 5x. Finally, divide out by 5. X equals 14/5. Now in some of the problems, you do need to check your answer when you're dealing with logs. The only thing you would check for is just to make sure you can never have the log of a negative number. So what's in the parentheses, which is the 5x minus 6, your answer needs to make sure it makes a positive number. If it somehow makes that value negative, then it doesn't work. There's no solution. That actually comes up later and usually happens when you get 2 solutions. You definitely want to check because a lot of times one of them will work and one of them will not. Okay, here's another log. It's very similar to the last one we worked. We have the log 1 minus 3x equals 2. Alright, so when you see a log equals a number, we know we have to get rid of the log, and we can do that by converting. So remember, just like we have before, convert to exponential form. Remember, we start with the base. Now, if you notice, there's no base written, but remember, when you don't see the base, that's an understood 10. So this would be 10 to the 2 equals 1 minus 3x. Okay, and that leaves us something nice and simple and pretty easy to solve. See, let's subtract 1 to the other side. We get 99 equals negative 3x. And finally, let's divide out by negative 3. We get x equals negative 33. And that's our answer. All right, now we get to the last kind of logarithm equation that we'll see. If you notice, in the equation, we have log and log on either side of the equal sign. So this is where it is a little bit different. Okay, in the past ones, we've had log and then there's like a number on one side. But this one, we have logs on both sides. This is kind of nice because we can use the rule, if we think about it, if both sides are equal and they both have log of the same base, then in many ways, you think about it this way, is you can drop the logs and just set the terms equal to each other. Okay, it's probably not officially the correct way to say to drop the logs, but that's kind of what you're doing. You're just ignoring those and setting the others equal. And then this leaves just a basic quadratic for you to solve for. So remember, solving for quadratics, let's bring everything to one side. So let me bring 3x to the left side. I've got to subtract it, leaving 0 on the right side. And let's see, it should factor. Okay, let's see, 10 is 5 times 2. And it does factor, so we get 2 possible solutions. X could be 5 and negative 2. Okay, this brings up a good thing here. We have 2 possible answers. When you're dealing with logs, you must check your answer, especially when you came up with 2 answers. And you're checking to see that these numbers, when you plug it into the original function, it cannot make the parentheses negative. You can never take the log of a negative number. So, for instance, if you plugged 5 into the original problem, you would get 5 squared, which is 25 minus 10. That's positive. And then on the other side, you would get 3 times 5 is positive 15. So 5 works. Everything's great. But when you plug in negative 2, if you plug it in, you have negative 2 squared is 4, minus 10 is negative 6. Okay? You can't get negative 6. That does not make sense. Therefore, negative 2 cannot be part of the solution. So we only have one answer. So please remember, in this case with logs, you need to check. Okay, so for our final 2 problems, they're kind of similar. If you notice, we have log base 6 plus log base 6 equals 2. So we have 2 log terms on the left side of the equation. So what we're going to have to do in this case is we need to combine those into one log. That's what we learned in the previous section when we were learning those properties. We were learning how to condense 2 different logs into one log. So since they're both log of the same base, we can combine them into one log. And if you remember, when you're adding between the 2 individual logs, that means you multiply the terms when you combine them. Okay? So we've combined them into one log. Now we solve it like we normally have. We've got to get rid of the log, so we have to convert to exponential. Convert. All right, so that would be 6 to the 2 equals all of this. Looks like some big numbers, so let's think about this. We have to FOIL it out. We have x squared see what 4 times 39, that is, let's see, 36, 12, 156. Let's see, we've got x squared plus 43, 156, and let's subtract 36 to the other side, so we'll have 0. That gives us x squared plus 43x, let's see, plus 120. So it's some kind of big numbers, but it should factor. And so let's think about it. Okay, we need 2 things to multiply to give me 120 and add to give me 43. So we know that 12 is 4 times 3. So if we did 40 times 3, that would give me 120. And that would also add to give you 43. So if we set each of these equal to 0, and solved, we get two possible answers, negative 40 and negative 3. Okay, but we definitely want to check. Remember, you just take the number, plug it into the original function right up here, and just make sure that inside the parentheses you don't get a negative. So let's look at negative 40. If I plug negative 40 into the first one, I get negative 40 plus 4. That clearly is a negative number. That makes no sense. So negative 40 does not work. So let's check negative 3. If I plug negative 3 in, I get negative 3 plus 4 is positive 1. And negative 3 plus 39 is clearly positive. So negative 3 works, and that's my answer. Okay, and finally we have a log very similar to the last problem we had, except if you notice we have a subtraction between the two logs. So we do need to combine those into one log, right? And when it's subtracting right there, when you combine them into one log, you divide the terms. So we'll divide them, but it's still one log, but you divide the terms. Okay, so from here we can convert to exponential. Let's start with 4. 4 to the 2 equals that big old fraction. And this is what we have. Now we're left with just solving this equation. Let's see, 4 squared is 16. So let's just solve it. Let's get rid of that denominator so we can multiply both sides by x minus 2. X minus 2. Alright, these cross out. We get, let's distribute 16 through, and I'm going to do it over here. Okay, so that's 16x minus 32 equals 4x plus 1. Let's subtract 4 to the other side, so minus 4x. And plus 32. Sorry. That gives me 12x equals 33. Final steps, divide out by that. Now let's make sure 33 over 12 can be reduced. If you take a 3 out, you get 11 over 4. So my answer is 11/4.